All right. It only took a whole day for me to finally get to this, so I do apologize. But I wasn't too worried because pretty much we ended on a closure that I knew that this was going to happen. So hopefully you guys are surviving your first day of online school. So this probably won't get to you till Friday. So once again, I apologize. But it's going to suck. I'll be honest. This is going to be really weird for the next few weeks. I'm pretty sure we won't come back within a week, especially recently. If you haven't heard, Gavin Newsom just kind of pretty much locked down California. So we'll see how that goes. And I hate rules, but here's some rules, or at least I hate going over rules. So here's some rules that I do like to go over. And the main thing is just to be nice to one another. So this is new to me. This is new to everybody. So we want to make sure everybody's doing a good job. My goal is just to present material. I don't even know if we're going to come back for START or SBAC testing. I really don't know how everything's going to look. So we're just going to go week by week and see how this virus takes us. And my goal is to deliver content just like before. As long as you complete everything, you'll be in good shape. And I'm going to try to be as flexible as possible. So if there's anything going on, let me know. Just be vocal. Let me know. If somebody needs something, just let me know. Be kind. We probably won't have any discussion like questions, but you still have those Google discussions slides that you could kind of talk about. So just be kind to another. Be respectful for one another. Be kind to your parents or your family. It's going to be crazy that you're going to be home for hopefully not forever, but at least a few weeks. And try to be happy in the situation that you're in. So, if it's whatever it is that makes you happy, do it. Reading, singing, playing video games, whatever. Find some way to relax. Kind of to start us off, I've been playing this for one of my class. This is kind of how I am at home because right now I am by myself. My wife is still working. So I am trying to juggle doing stuff and taking care of my son because my parents cannot be with him. So hopefully this is funny to you because it was hilarious to me. So enjoy.
Of course, everyone's been out buying supplies. Personally, I recommend CVS. They've got what you need, and every receipt is a week's worth of toilet paper. Hey, you stepped on that trick. That's a funny joke. Do you like it?
No.
All right. Everyone's been buying supplies. Personally, I recommend CVS. They've got what you need, and every receipt is a week's worth of toilet paper. Of course, everyone's been out buying supplies. Personally, I recommend CVS. They got what you need, and every receipt is a week's worth of toilet paper.
Toilet paper.
I told you it was funny. I knew you'd like it. Just gotta wait for the punchline. Okay.
All right, so hopefully you enjoyed it. And my other, I think physics, he totally jumped into my screencast and just made life hard. Before it was used to be just my dogs, but now they're so old that they don't really want to bother me anymore. They just want to be left alone. So he's just my lap dog. Anyway, grades. To be honest, just read the last line. I just want things to be completed. I'm going to deliver content. And I'll be honest, most likely things are going to be done at home. There won't be any test at school. So it's going to be an honor system. I just ask you don't cheat, but most likely everything's going to be open notes anyway. So we're just going to finish up magnetism and electricity and then just go over astronomy. So that's pretty much what we have left. So it's not too bad. And most of the stuff is not very mathematical. So it's not that hard to test like on multiple choice or things like that. So we'll just see how it goes. If you haven't heard, SATs been canceled last week. APs, they're trying to figure out what to do. They even came up with the idea of AP take-home tests. So we'll see how it goes. But just be flexible for everybody. Everybody's trying to figure out what's going on. Everybody's trying to think, trying to see how long it's going to last. And we're just going to have to be respectful. And remember what I said before, we're doing it for our parents and grandparents. So even though it sucks being home all the time, we're doing it for them. All right. So this is kind of going to be the breakdown where I'm going to have probably like a 10 to 15 minute lecture or a screencast, which is what I'm doing now. I might show some demos. Most likely there will be YouTube, because all my stuff is at work and we're not allowed to go back. So I'm going to utilize a lot of YouTube and FETs. We'll just have quizzes just to kind of have things. And a lot of times I might have one like question or one problem every day, just to keep us, like, that's kind of just a point going thing, and just to keep attendance and making sure that you are at least listening to me at least once a day. So that's kind of how it goes. If you ever have like a crappy week or something, or let's say you have responsibilities at home that really prevents you from doing certain things at certain times, just let me know. Like I said, I'm flexible. I understand. Some of you might have different responsibilities. Some of you have absolutely no responsibilities. So it really just depends on who you are. So just let me know if that's the case. This is already out of date. This was, I think, 2 days ago, where they said 2 weeks probably isn't enough. 8 weeks is probably the best for school closure. But who knows how it's going to go, because, like I said, Gavin Newsom kind of just dropped the bomb saying California is on lockdown. So you only go out for groceries or emergencies, and that's it. We get to stay home, and you guys, I guess you guys get to play Animal Crossing. Yes, Animal Crossing. All right, so good luck with that. So let's go on to kind of the review part. So I never posted up an answer key, but I will. But I also wanted to kind of go over it with you guys and just make sure everybody gets it as well as we're going through this. So let me choose. Let's do dark blue. All right, so magnets attract, other iron, nickel, and cobalt. So those are the three main things that it's going to attract to. And that's it. So, I mean, it's technically electromagnets. But that's about it. So they attract to those things. Has to be iron, nickel, cobalt. When it comes to poles, opposites attract. So you have north with south, or the opposite, south with north. All right, let me put my dog down. He's getting annoyed. They repel pretty much same pole. So north with north, or south with south. So that's pretty much it. On the test, what I'm gonna do is I'm gonna post it up Monday. You have a day to complete it. You could use these videos to help you out. Like I said, I'm just delivering content. I just want you guys to listen through it. I've never been too harsh on certain things, so it's even going to be more lax now. But that's just kind of how it is. So at least you have one cool thing. So let's say you had a paper clip right here, and then you had a magnet on the bottom. So out of this magnet, you have magnetic fields coming out and magnetic fields going back in on the south end. What these do is they reach out into its environment. Some eventually do loop back, but because it loops out, it's going to have an attraction force to the paperclip, which is iron, nickel, cobalt. So as long as the paperclip is within this magnetic field, it's going to be attracted to it. Now, sometimes it might not have enough attraction to it because of what's it called? Actually, I should have drew this the other way. They didn't have enough attraction because it might not be close enough, but it's going to feel, technically I should have done it like this. The paper clip attached to the table, and it's attracted to the magnetic field force because it's being pulled up. So either way, it's going to work, but it's within the field it's going to be attracted to. Now, if you do put something in between, will it still work? And the answer is it depends. If you put a piece of paper in between here, nothing will happen. Nothing will change. So what I mean by that is the paper doesn't disrupt the field force right there. But if you put iron, nickel, or cobalt in between, it will affect the magnetic field. So it'll either increase or decrease. If you put a magnet in there, it's going to increase it. If you put just a non-magnetic iron, nickel, cobalt, it will actually make it weaker because some of the strength has to go into changing the domains in these things. So it just depends on what it is. So hopefully that makes sense. Magnets attract iron, nickel, cobalt, north-south or south-north. Magnets repel the same pole. And it has a magnetic field, so as long as you're within that magnetic field, it's going to feel it. Now, most things can't affect it unless it's iron, nickel, or cobalt. And that's kind of why we kind of feel Earth's magnetic field, because it kind of travel through things as long as it's not iron, nickel, or cobalt. So let me just trash this and move on to the next set. So I know the north and south is a little bit off, so I apologize. But let's just pretend it's over here. South. Whoa, what happened? South. 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 All right. So magnetic field lines around each one. So here it's going to come out of the north, go into the south. Notice that the lines never touch. And they're more concentrated on poles. So eventually they're going to wrap around to the other side, because that's the goal. The goal of the arrows is to go move from south, north to south. North to south. So if you had another one here, even though that's not part of the problem, but let's say you did have another magnet here and this was the south, instead of going all the way around, it's just gonna go straight to. So this is if it had another magnet there. All right, in the sketch below, show the domains if it loses magnetism. So here all the domains are going to be pointing inside, so it kind of looks like the line is continuous. So it goes from the butt all the way through the magnet out to the front. If it loses magnetism, these domains are just going to be random. And every other way, I guess you could think of it as just canceling each other out as they go through. So that's what it is. So describe one way to make a magnet, and that's the video that we watched, and it's actually pretty straightforward. Let's say you had a T-pen, and these domains are in every direction. So it's not in any direction at all. And then let's say you got a magnet that's a north and a south. So as you're scraping it across that way, all these tips of the arrow is going to move in a certain direction. If you're holding north, these tips want to come out of the north. So what eventually will happen is if you do use north, then all these arrows are going to point this way, because as you're scraping the north to this side, the butt of the arrow wants to be coming out of the, or pointing at the north. Remember, the point of the arrow is pointing at the south. Now if you did the same thing, I should have made that thicker. If you did the same thing, but instead of using north, you use south, and it rubbed it across, then the arrows will point this way, because if this was the south, arrows are pointing towards the south. So that's one way to make a magnet. This is a physical way. Another way, which we kind of didn't have time to do, is get a coil of wire and make an electromagnet. Actually, we did have time. I forgot. So if you do that, you still get your magnetic field, and it look exactly the same as a barg magnet, as long as you have current going through the wire. Okay, so either way is fine. We actually did both ways in class. We did this way, and we also made electromagnet, which is loops of wire. Okay. All right, so for the right hand rule, the thumb represents the current, and the fingers represent the magnetic field. And since your hand can only grab in one direction, so here's my right hand, I can only grab my pen when it's in front. If it's behind me, my hand can't bend the other way, so there's no way I can physically grab it. So if it's in front of me, I could grab it, and then that where my finger rotates around the item is the magnetic field that's going to go around. So if that's the case, we probably won't do this on the test just because we really haven't spent much time on this one. If I was there physically with you, it would be a little bit different, but since I'm at home, it's kind of harder to show this. So it won't be on the quiz or the test on Monday, but I do want to kind of go over what's going on. So when you have compasses here in front, ooh, why does it keep doing that with my pen? In front. Here it's in front. Here is behind. Here is also behind. And then here is below. So what I mean by in front, so you're putting the compass on top of the wire, and the reason why I know it's in front is because you don't see the wire. The compass is taking over. Here is behind because the wire is on top. Here is behind because the wire is on top. Here is below. So if the current is going from positive to negative, that's the current, I, then we can figure out what it is. So on the first one, the current is going down. So my thumb has to be in the same direction as my current. I'm going to grab the wire with my finger. So if it's in front of the wire, then my finger is pointing, in this case, to the left. So if it was here, it's going to be pointing to the left. Right. Hopefully you could do that at home. On the bottom one, here's my wire. The current is moving. Gosh, it's moving this way. I'm just trying to make sure I'm doing it the right way with you guys. I'm going to grab with my thumb. It's going to curve out this way. So if this was my thumb curving this way, behind my hand's going up. Okay. Here's behind. Current is up. So my fingers are going, in this case, to the left. And if it's below, so here it is, current's this way, below, my fingers are going this way. So you'll see, let me make sure I got that right, NX. Like I said, this is not going to be on the test, but since it's on the review, I wanted to go over it. It's so much easier to show you in person. It's kind of difficult to see it in real life or on a piece of paper. All right, so for the last one, you have, or last few, you have the following. So draw a bar magnet inside. If this was a bar magnet, remember this is the North Pole and this is the South Pole. But for a magnet, this is actually the South and this is the North, because compasses are pointing towards the South, but we define it as North. It's going to go out of the North into the South. So magnetic field lines will look like that, loop around the Earth, and creatures use it to navigate. And every so often, about 30,000 years, it does flip. How do speakers work? You have a permanent magnet on the bottom. I'll draw it over here. And then you have a loop of wire that's hooked up to your phone. Let's just draw an iPod from the past. And what happens is when it's on, it either attracts or repels, and then when it's off, it doesn't do anything. So it just, this thing will make either the magnet goes in and out, or the coil of water will go in and out, and then it's attached to a diaphragm, which will then vibrate your air. So that's kind of how a speaker works. A motor is very similar. You have north and south, and then you have your loop of wire. So just go back to that lecture or the video that I showed you. On one side it's north, on the other side it's south. So when it's on, it's going to repel in this case, and when it's off, it's going to do nothing. So that's kind of how it works. For the next question, I believe, which is a generator, So a motor. So if this is the motor, if you, I probably should not have used yellow. Yellow is not good. Okay, so if we input, output, if you put in mechanical energy, and that's motion, you get electricity. And if you do the opposite, if you put in electricity in a motor, you get motion. So motors are really cool because they work in both directions. In one direction they move forward, in another direction they move backwards. So if you give it motion, it produces electricity. If you put in electricity, it gives you motion. All right, so hopefully that's a good review. I apologize it took me so long to do. Life just kind of made it hard with my son being home with me. So it's a bad excuse, but it is an excuse. So hopefully that helps. The test will come out. Actually, I might actually just post it late tonight so you guys can start working on it. So let me know if you need anything. I'm here to help you. We can get through this. Hang in there, and I'll see you next time.